We are going to continue looking at best fit linear models here. We're going to go over to Alex for this assignment this week. And the first thing that we're going to do is we're going to actually start drawing the lines of best fit. And Alex has a real nice line tool to do that for us. And the thing to keep in mind is it doesn't have to be perfect. It just has to be kind of a good approximation. So if you see what I have here, this is perfectly okay. Remember, the idea of a line of best fit is to try to minimize the distance from each point to the line. So kind of going right down the middle of all the points is really the best thing to do. If we went up here like this, notice it was kind of like the same slope, all right, so the same steepness, but it's kind of far away from a lot of those other points now. If you look at, these points around here, those are kind of far away from the line as opposed to where it was right in the middle. Now, yes, it does go right through, this point here and these points here. All right, so that's good, but we want to be able to minimize the distance between all of the points, not just a couple. So don't just pick 2 points to go through. Try to make it go through the middle so that, like we said, that distance is minimized. So somewhere around there is good. And if it's here, that's okay. If it's here, that's okay. Like, it doesn't have to be perfect. Notice it says in the parentheses, it doesn't have to be the exact line of best fit. Just draw your best approximation. There is a way to draw the perfect line of best fit, but it usually involves a lot of computers and a lot of calculations that machines do instead of humans to figure out what it is exactly. So that's why it says just be close here. All right, so that was good enough there. I'm just going to run through a couple more. This one, just as a review, has a positive correlation. So this is going to be going up. And actually, let me show you why this is not a good line of best fit. All right, even though they said it was correct, I totally disagree with Alex there. That line should have definitely been in the middle of all of those points. That's way too far away from all the other ones. So I'm going to disagree with Alex here. But we're gonna move on. They probably just appreciated that it had the same slope. So here, so they're giving you a lot of leeway here. You just have to be close to where it is, and this is good. Here's another one. So these hopefully are kind of some free points for us here. All right, now let's start looking at some other ones. All right, so this is a review of what we did last week on Study Island. What type of relationship is this? Is it positive? Is it negative? Is there even a correlation at all? And then also we've got linear and nonlinear. Looking at these, I'm gonna bring up my little marker here. I could draw a line of best fit through these. I can draw a line of best fit through these. And I can draw a model through that last one, but it's not a line. All right, so that one definitely, that's a curve. So we looked at last week the difference between linear and nonlinear. Linear obviously meaning there is a line. That's why the word line is actually in linear. So both of those are linear. And then figure one, there's nothing going on in there. As x increases, y does whatever it wants to do. So there's no association, there's no correlation for figure one. So let me get rid of these so we can go through the answers here. Which data appears to show no relationship? That's definitely figure one. B, what data shows a negative but linear relationship? That's figure three because it's going downward from left to right. Positive linear is figure two, and then nonlinear is figure four because it was more like a curve and not a line. Now, there's definitely a relationship with figure four. It's just not a linear relationship. Looking at number 6, same idea. Nonlinear, we're going to look at figure 4. B, what has a positive linear relationship? That's figure 1. That's almost a perfect line there. Negative linear relationship looks like 3, and then no relationship at all is 2. So same as last one. So let's get through that quickly here. Same thing here, positive linear relationship, figure 1. Negative linear is figure 4. Nonlinear is figure 3. All right, and then no relationship is figure 2. Now this is where the real math really starts to come into play. So here's an example of a scatter plot where they give you the line of best fit, and more importantly here, they give you the equation for the line of best fit. All right, so right here is the equation. All right, and this is where math really comes into play. So we use a line of best fit, we use this data in order to make predictions. And they say this equation will give us the best prediction from this data. All right, now obviously this prediction came from these points, but it doesn't mean every single point is going to be on here. So when it says use this line to make a prediction, you use the line and this equation specifically, you don't look at the points. For example, let's say that they wanted to know about someone that was watching 28 hours of television. How much time would they be spending on homework? Well, if you notice, we've got kind of 3 people that are around 28. And not a single one of them is actually on that line. But when we're using a line to make a prediction, we would talk about, we would talk about that point right on that line, right there. All right, that is what we would use for a prediction. And more specifically, we would put 28 in for that X. All right, so let's go ahead and take a look at what the problems are asking us here. So it says, what is the predicted time spent doing homework for a student that doesn't spend any time watching TV at all? So if you don't spend any time watching TV, that means we put 0 in for X. And if we put 0 in for X, that gives us our y-intercept. All right, so if we're looking at this equation right here and we put 0 in for X, it doesn't matter what we're multiplying 0 by, we just get 0 anyway. All right, and then that's plus 26.08, and 0 plus 26.08 is just 26.08. So part A is going to be 26.08. Part B, for an increase in 1 hour in the time spent watching TV, what is the predicted decrease in the time spent doing homework? All right, and this is where our understanding of this type of line comes into play. And hopefully you recognize this as slope-intercept form, where it is y equals mx plus b, where m is the slope and b is the y-intercept. But when we're dealing with situations like we are here, we don't want to think of them as slope and y-intercepts. Y-intercepts, we call this the initial or the beginning amount. So if we started at 0, what would we have? And that was the answer to the first question. We start at 0 hours watching TV, we would have 26.8 hours doing homework. The slope is also referred to as the rate of change. So how much is something changing? Rate means like you're comparing two things, so we're comparing hours and homework, and how much are they changing in relation to one another? And that is the negative 0.077. So every time we spend an extra hour watching TV, we spend 0.77 hours less doing homework. So that's how we would answer this next question, is 0.77. Now we don't need to put negative here because the question already says what is the decrease going to be. So they already took that into consideration, so we don't need the negative. We're going to keep it just 0.77. All right, now comes using the actual equation part of this. And it says, what is the predicted time for 18 hours of watching TV? So this is just like we've been doing with formulas, with algebraic expressions. We are going to substitute a value in for the equation that we know. So instead of x, we're going to put 18 in for in for the x, and we're just going to follow the order of operations. So we're going to do this multiplication first, and then add 21 or 26.08. That's bad, in case of bad handwriting there. You can use a calculator, obviously. I'm going to go ahead and put this into my calculator. So negative 0.77 times 18 is negative 13.86 plus 26.08. That gives me 12.22. So 12.22 hours spent on homework here. So let me put that in. 12.22. Go ahead and check. And that is correct. So the other thing I want to make sure that you are not doing is don't use the points. Make sure you're using the line once again. So when it says 18 hours is right about here, right in between 16 and 20. So we go up to where the line is, and you see the line is just over 12 at 18. All right, but there's a point right here for 18, and that's over 16. So when we're using the equation, you don't want to use those extra points. We're using the line, and that's kind of a way that you can check your answer to make sure that you did it correctly. We got 12.22, so when you go to 18 on the line, make sure that's about 12.22, which it is. So we're good to go here. So let's move on to the next question. It's going to be very similar here. All right, so for an increase of 1 year of experience, what is a predicted increase in hourly pay rate? All right, and this is another rate of change problem. I'm going to talk about this a little bit differently this time to get that deep understanding. We know we talk about slope as rise over run. And let's think about rise deals with the y's and run deals with the x's. Let's talk about what the y's and the x's mean here. So the rise or the y's are pay, obviously, in dollars, and the run or the x's are the year's experience. So basically, like, how much is the pay changing per year? And that's what this question is asking about here. All right, for an increase of 1 year, so when x increases 1, so when we go over 1, how much do we go up? All right, which is exactly rise over run, which is exactly the slope. So when we're looking at this, y equals mx plus b, we're trying to identify the m, which in this case, 0.96. All right, so just another way to kind of look at finding the rate of change or what that rate of change means. B, what is the predicted hourly rate for a cashier who doesn't have any experience? Once again, that is our y-intercept. What is the beginning amount, the initial amount? So no experience at all. That's 8.14. And then, of course, the last one is going to talk about, let's use that equation, once again, to make a prediction for somebody that has 5 years experience. So we're going to go ahead and put 5 in for x. So substitute a value in for the variable, and x talks about experience down here. So that's why it makes sense to put 5 in for x here. And I'm going to go ahead and type this into my calculator. 0.96 times 5 is 4.8. And 4.8 plus 8.14 is 12.94. Now, before I put that in, once again, I'm going to look at, does this match up with our line? So we go up to where 5 is, and then from there we go over. I went over a little crooked that way. But if you go over, that's definitely matching up to right in between 12 and 14, so close to 13, which is what 12.94 is. That's close to 13. So let's go ahead and put that in, 12.94, and move on to one final problem here, which is going to be similar to what we just did. All right, so really the focus here, excuse me, the focus is all about this equation, y equals 1.87x plus 11.26. All right, 1.87 is the slope, that's the rate of change, 11.26, the beginning amount. So I'm not even going to pull up the marker here, I'm just going to talk about what is the predicted amount of money spent on entertainment for a student who doesn't do any work. So the 1.87x kind of disappears because we're putting 0 in there. So that's 11.26. The next one, for an increase in 1 hour of time worked, what is the predicted increase of money spent on entertainment? That's our rate of change. So that's 1.87. And then I'm just going to bring up the calculator this time to show you what we're doing here. So we want to know, what about when we put 8 in for x? So I'm going to put 1.87 times x, which is going to be 8 in this situation, plus 11.26. And we get 26.22. So as you can see, I am making your assignment on ALEKS for this week. And that's literally what I was just working on. I just went through kind of a practice run of your assignment. It is called Sketching and Predicting with Lines of Best Fit. So you're making those lines of best fit, and then you're making predictions based on those equations. And it's 10 questions. If you need any assistance, I will be available in my Zoom rooms at the scheduled times in your emails and through email if need be, but Zoom is so much easier to explain. Good luck and reach out if any help is needed.